How orifice plate flow measurement works. An orifice plate is a primary flow element used to measure fluid flow, liquids, gases, or steam inside a closed pipe using the differential pressure ΔP principle. 1. The physical principle. The measurement relies on two fundamental laws of fluid dynamics, the continuity equation and Bernoulli's principle. Flow restriction. A thin metal plate with a precisely machined concentric hole, the orifice, is clamped between flanges perpendicular to the fluid stream. Velocity spike. As fluid approaches the restricted opening, its cross-sectional area decreases. To maintain a constant mass flow rate, the fluid's velocity increases rapidly through the orifice. Static pressure drop. According to Bernoulli's principle, an increase in kinetic energy velocity causes a corresponding decrease in potential energy static pressure. Vena contracta. Just downstream of the plate, the fluid jet contracts to its narrowest area, called the vena contracta, where velocity is highest and static pressure reaches its lowest point. 2. Differential pressure ΔP generation. Two impulse taps are drilled into the pipe or flanges. High pressure tap P_1 located upstream of the plate where static pressure is high and velocity is low. Low pressure tap P_2 located downstream near the vena contracta where static pressure drops. The measured pressure difference between these 2 points defines the differential pressure. Delta P equals P_1 P_2. 3. The flow rate formula. The volumetric flow rate Q is proportional to the square root of the differential pressure delta P. Q equals C CDOTA_2 CDOT SQRT frac 2 CDOT delta P rho. Where Q equals volumetric flow rate. C equals discharge coefficient accounts for fluid friction and velocity profile. A_2 equals cross-sectional area of the orifice bore. Delta P equals differential pressure P_1 P_2. Rho equals fluid density. Important field note. Because Q propto SQRT, delta P doubling the flow rate increases the differential pressure by a factor of 4. A DP transmitter or control system PLC DCS must apply a square root extraction to convert the nonlinear delta P signal into a linear 4 to 20 mA flow signal. 4. Core hardware setup. Component function orifice plate primary element creating the pressure drop available in concentric, eccentric, or segmental profiles. Impulse piping transfers process static pressures P_1 and P_2 to the transmitter. Valve manifold 3-valve 5-valve enables inline zero calibration, equalizing, and safety isolation without process shutdown. DP transmitter measures physical delta P, executes square root extraction, and sends standard 4 to 20 mA hard signals to control systems. Practical considerations. Advantages. Simple design with no moving parts, low initial cost, standard calibration standards ISO 5167, AGA 3, and wide suitability for high-pressure temperature applications. Limitations. Causes permanent pressure loss, unrecoverable head loss subject to edge wear or slurry buildup, low turn-down ratio typically 3:1 to 4:1 and requires straight upstream-downstream pipe runs to prevent flow turbulence.